So this is a Geneva mechanism, and they're astonishing actually. They're really quite cool. They used to find a lot of use in cine projectors. These days they're very useful for pick and place machines or actions that you want to be definite and then held. So it has a really interesting property. Here's the input wheel. It's got a pin on it there. As the pin moves, it pushes against this star, and then the star moves around to that circular section, which locks it in place. So it will continue to move round, but this can't move. Then it comes right the way around into the next slot and moves it on by one slot. So if you want to repeat an action, control an action, time an action, then this is a pretty good option. Unfortunately, of course, if you want to do it a certain number of times, you have to troll the net to find one of these that has the right number of slots, and sometimes that's not as easy as it might sound, and sometimes it's not quite right when you find the actual thing. So I think it's always better to be able to make these yourself. Now, surprisingly enough, it's actually not that difficult. It's a few basic things that, as long as we keep in mind when we're working out how to draw this and how to make it, turns out it's pretty easy. And it's all based on a right-angled triangle. Now, all triangles add up to 180 degrees. Of course, the right angle means it's 90, and then we have two more angles. One we don't know. The one we don't know is the one that we can work out from the number of slots we've got. If you take 180 and divide it by your number of slots, and in this case we've got 5, so 180 divided by 5 is 36. Means we've got to make a triangle of 36 degrees. The other angle will be set, and that'll be 54. But we need a 36-degree right-angled triangle as the basics of what it is that we're going to do. Now, if you're doing another CAD package, of course, you can just set those angles. Tinkercad has a couple of quirks that enables you to do some accurate geometry, so we can actually draw this in Tinkercad. Right, we're in a brand new file. The ruler is found here, right there. I click it and place it in that corner, and it will have a little symbol by it there. If I click on that, it's got use endpoint. If I click on it once, it's use midpoint. What that does is measures from where this dot is to the midpoint of the object, obviously. And when we use endpoint, what that does is go to the point that the object actually starts at. So let's leave it on use midpoint for right now. The other thing that we're going to need is this work plane tool here. So let's put an object on the workbench so we can see what that actually does. If we place that triangle there, then because we've got use midpoint, what it's doing is measuring the lengths of the sides and measuring where that midpoint is. And you can see that in green here. So the midpoint of that object has these coordinates, -99 and 101. That's where it's sitting, more or less, at the center of the plane. So the other useful tool is found here. It's the work plane tool. You click on it, hold down the mouse button and shift it, and when you move it to the object, it will sit on an object plane. Release the shift key, and now that plane is actually level with that. That will become very useful soon. To get rid of that and put it back to the default plane, click on the work plane and just put it somewhere in the space, and now the object is sitting where we originally placed it. Now if we click on that, we can see the coordinate to the midpoint. If we change that to use endpoint, the coordinates will change. The coordinates are taken from that point there, and we can read different coordinates. Those two tools are going to be immensely useful for placing accurate geometry. So, 3 bits of information. The ruler tool to measure a couple of things, the plane tool so that we can change our perspective, and that little thing about dividing 180 by the number of slots so we know what the angle is. Armed with those 3 bits of information, we can now set out to draw this. To draw this, we need 3 circles and 1 right-angled triangle. To start this, we need a cylinder. So let's grab a cylinder and pop it on the work plane. Now that cylinder's 20 by 20 by 20, so let's make it 80. That's just a random choice, incidentally. Making it 5 millimeters high will allow us to see the drawing as it progresses, and 80 by 80 is just what I've chosen to do. Now we need to create a right-angled triangle. Unfortunately, in Tinkercad, doing that accurately actually isn't that easy because you do get triangle primitives, but the ways of changing them makes it a bit difficult to know what's going on. So we need to create a right angle triangle with a 36-degree angle, and that's the problem. To do that, however, there's a neat little trick we can use by taking the semicircular cylinder primitive, reorienting it, resize it, and then we can place it on the actual cylinder covering half. Now we duplicate that and then rotate that along with the cylinder underneath it 180 degrees. Then we can rotate it exactly 36 degrees, and that's going to be the basis of our triangle with an accurate 36-degree rotation. Now, of course, we need to make it a right-angled triangle. To do that, we're going to use a square, a cube primitive, because cube primitives, of course, have a right angle, and we need to match it up, and we need to match it up to this plane right here. To do that, then we put a plane in place. That means that we're now going to be absolutely parallel to that section that we need, and we can drop the cube to it, and then we can go back to the original plane and place that cube. And we do that using the alignment tool so that it aligns perfectly with that edge there. Then we stretch that out until we make it much bigger than we want it to be. Now we want to get rid of a section, this section here. Again, to do that, we can use the plane and put a plane on this bit here. We add the plane, well, now anything we do will be in line with that there, and we don't have to worry too much about it. We want to chop a bit out. Now we drop a cube on there, a hollow cube this time, but this time it's above the plane, and we actually want to get rid of the bit below the plane. So if we make that minus 20, it'll move it below the plane, and we can rotate around to see where we are. We're on the other side of the plane. Now we need to stretch that cutout so that it will cut out what it is that we want it to do, and we make that ridiculous. Now we go back to the original plane so that we're working in that plane, and we can see that we've cut out basically a right-angled triangle. And what we can do now is merge the two. So drop it down to the plane, merge the two, and then get rid of our construction semicircles. And what we can see is that we've got an 80 millimeter diameter circle and then a right angled triangle with the center at the center of the circle, and this edge here is in line, or rather a tangent to that circle there. Now we need to create a second circle. A circle with this radius, that point at the center, that radius means that the circle that we draw here will intersect where the right angle of the triangle and the bigger circle meets. Of course, for that, we need to know what that radius is. And that radius is actually relatively easy to discover. Place a plane on there, and then if we click on that, we'll get the actual size of that, which is 29.06. Let me go back to the original. Now 29.06 is the radius, so we need to double that to 58.12 and create yet another cylinder. This time the cylinder is going to be 58.12. There it is. Now all we need to do is place that on the edge right there, because that is the center. And there's a neat little trick. If we pop there, we can see that that says use midpoint. That means is all the measurements are taken to the centers of things. If we change that by clicking on it, it will change to use endpoint. Now if we click on that there, what we'll get are the coordinates of that point there, and we can see that it's minus 112 and 80.94. These are the green arrows. So if we set that circle here, go back and now use midpoint. If we set the midpoint to the previous coordinates that we just read, what we'll get is that circle centered on that point there. So this one, we change to minus 112 And this one we change to 80.94. There we go. And now that circle is centered on that point of the triangle, and that circle is centered on that point of the triangle. Now there's one more circle that we need to add, and that's the circle that comes from that center to that point there. Now that point there is the one that we need to know. If we flip that up again, and this time we put a plane on that edge, if we click on the triangle, then we can read how long that triangular edge is, which is 49.44. Then we can go back to the original plane. Now we know what that distance is. We just read it, and that was 29.06. We know what that distance is. We just read it, and that was 49.44. If we take one away from the other, we get 20.38, which is going to be the radius of the circle with that at the center, touching that point there. So we double that to 40.76, and then we can add another cylinder. And we make that cylinder 40.76. Now we can just center that cylinder to that cylinder by highlighting the two and using the centering tool. So if we hit Shift and click, use the centering tool, center to this, there we go. That actually currently is off the base, drop it down, there we go. And we can see that construction drawings are now done. So the trick of using the planes and swapping between endpoint and midpoint is how we can lay out some very accurate geometry, which is the basics of what we need. So that was the complicated part. The rest of it is pretty much just laying on shapes. And to be honest, apart from the little triangle drawing that we had to do, you would be doing exactly the same thing in any CAD program. You need to work out what those circles are, which means you need to know those lengths, and then they need to be held in relation by the right-angled triangle. And you do that whatever program you're using. Tinkercad is the same as any other program, apart from the little trick that we needed to create that accurate right-angled triangle. Now what we're going to do is use that construction drawing to lay out the rest of the shapes and build our Geneva mechanism. Now what we need to do is create the slot, and we create the slot using a cylinder primitive. Now I'm going to choose 6mm as my slot size because it's just a choice that I think is reasonable. And I'm going to make that 8mm high so I can grab it, but it's still in place. We need that first hole to be right there where the triangle intersects with the circle. But in this orientation, we know that's perpendicular, and we know it's perpendicular to this. So we can take the hole and the inner circle, and we can align them by pressing the Align key, and we align them to the center and this edge here. Now the edge is actually on the inside of the circle, and we need it to be directly on the circle center to center. It's 6, so use the arrow key to move that down 3. 1, 2, 3. Now we can copy that using the copy key, and we can move that down to where the 90-degree angle meets that edge. But again, remember it's perpendicular, so we can do that by clicking on the copied hole, holding the Shift, clicking on the larger circle, aligning it, and this time aligning it to the bottom edge of that circle there. Then we can move that down by 3 because remember we want the center of the hole to be on the center, on the edge of the circle. Now if we highlight both those holes and merge them, we get a single set that we know is 25.62 apart, center to center. So we can pull down a cube primitive, a hollow cube primitive, make it 6, make this measurement 25.62 minus 6 because we want it to go to the center, not to the edge. So that's 19.67. Again, we'll make it the same height, which is going to be 8. And now we can center that and this together with each other using the alignment key. And we can center to this shape because we merged that shape to make it a whole. If we center the center, what we get is our actual slot. So when we merge those, that will be the slot where the pin goes, and the pin actually will sit right there. Now what we need to do is rotate it, because as you've seen, whenever we put anything onto the work plane, Tinkercad automatically puts it perpendicular to the work plane. At the moment, we've been working along that edge, which is fine, but we now want to work along that edge. If we try to put something on and get it to that edge, we'll be forever bending something by 36 degrees. So all we really need to do is make that the perpendicular. So highlight the whole thing, and then rotate the whole thing by 36 degrees. When we've done that, we've made that edge perpendicular, because what we need is yet another circle running in here that has its edge at that edge of the hole. This will all become clear when I draw it. What we do is take another block primitive, again make it 6, 20 will be fine, make it 8. Actually, let's make that a bit bigger, let's say 40. And this time we can align it to this. But remember, we made that a whole thing, so don't forget to ungroup it so that it's just aligning itself to that circle, that cylinder right there. Align it to the center, and the top edge will do fine. And we get something that we can use as a cutout going all the way down there, because what we need is the distance from this point to the distance to that point right there in order to be able to know where that next cylinder, that next circle needs to go. Now to get that, of course, we can take yet another drawing tool, which we're going to make 2 millimeters apart. We're going to make that 8 so that we can actually remove it. And let's make that about 16, something like that. Now we drag that away up here. Move around a little bit. And this is to get nice accurate alignment. Drop in another plane right there. And then we can drop this by hitting it and pressing the D key, and it will drop to that plane. Replace the plane. What we need to do now is line this edge up with this edge. So click on there, shift key, click on there, align tool, and align to the edge. Now if we hit this, hit that little drawing mark we just made, merge the two of them, then that length, 1408 plus 6, is the radius of the next circle that we need to draw. You'll notice the diameter is 40.16. That's because the radius we just measured was 20.08, and of course we need to double it for the diameter. I've already put an 8mm hole in there, so that'll be the axle point. And you'll notice as well, it's 0.6, because in all of these drawings, these are 0.5, and we'll be able to grab that at some later date. In order to do that, raising it by a millimeter makes it much easier to grab. Now, of course, we can center those two circles here and here, and we center it to that one. What we need to do now is make a cutout. The cutout is actually the big circle, but the big circle, remember, is 80, and we need a little bit of leeway, so I've created a cutout cylinder here of 80.2, giving us 0.1 of a millimeter either side as a bit of leeway. And we center that cutout to the big circle. Then when we've done that, we can click on the cutout, hold down the shift key, click on the small circle that we made, and then merge the two. And what we'll get is our cam. So that's the cam with the right size circle cut out of it. Now we need to cut out little slices from this big circle, which will in fact be our driven slot mechanism. In order to do that, what I've done is taken exactly what this was, which was 40.16, and again raised it by 0.2 of a millimeter to give us a bit of clearance. So we've got 40.36, and we're going to need to do this 5 times. So what we do is leave it to one side, copy it, center it to this one here, click on it, then click on the big circle and merge the two. Now we've got a cutout in that big circle. We need to rotate that around. If we do that currently, you'll notice that although we've got 80 here, we've got 76.79 there. So we can't rotate it just by grabbing that because it will skew it, and we don't want that to happen. What we need is a rotation guide circle a little bit bigger than that 80 by 80 that we previously had. So what we want to do is create a circle that's a little bit bigger. And there is it in place. It's 84 by 84 and it's been centered on that. Now, if I grab both of those together, it will rotate for the outer edge, and we need to rotate that 72 degrees because our initial rotation was 180 and it gave us 36. Twice times 36 is 72. So let's rotate that by 72. When we've done that, that's what we get with some nice chunks bitten out of it. Now we need to put the slots in. We have the slot drawn right here. So click on it, copy it, hold down the Shift key, click on that one, and group them. Then again, rotate it 72 degrees and repeat that procedure. And after you've done that 5 times, that's what you get. And I've also put an axle hole in just by creating an 8mm hole cutout and centering it to one of the cylinders. Now if we drag that off, there we go. We've got our actual driver for the mechanism. So the only thing that we're really missing is the placement of the pin. Okay, I just dragged this off to show you. Let's actually replace it and drag off a copy. So highlight it and copy it, and then drag a copy away. Because now what we want to do is put the pin in, and the pin is actually one of those slots. So if we ungroup it, we'll get the slot back. And that means that we can delete both the rest of the shape to get rid of it nicely out of the way, and we can delete that center hole because we don't need it. Once we've done that, we're left with this slot that we created. And remember, it was a grouped object. So if we ungroup that, then we can delete the elements we don't need, which was that hole there and the keyway that we put in there, leaving us with just this pin here. And we can create a pin out of that by turning it into a solid. Now it is 6 by 6, so if we wanted to, we could make it with a bit of leeway, 5.8 by 5.8. But you will also notice it's actually jutting out there quite a way, actually. And what we want to be able to do is have a bit of support. So we need yet another circle. So we'll just take that one, copy it, and make it something, I don't know, 68 by 68. Should be big enough. If it's not, we can change its size. Then when we've copied it, we can center it to the circle again. And we have a carrier for the pin. Now that was a copy, so it's 5. Let's make that a bit smaller. Let's make it 3. And then we can group that and the pin with each other. Now that pin actually has to sit in the center of that cup. In order to do that, we need to rotate it. Now we rotate it by 54 degrees because the pin needs to sit there or there. And if you remember, that angle is 54. This angle was 90. This angle was 36. And so this angle is 54 degrees. And so if we take that and rotate that by 54 degrees, then that pin is now sitting in the right position, and so we can grab it and move it out of the way. Once you've moved it out of the way, we need to merge it with this. In order to merge it with this, ungroup that so we've got an actual circle that we'll be able to merge with. We need to raise that by 3 because this is 3 high. It's still at 6. So let's change that to 5, which is what we want. We need to raise that by 3, which is where we needed to be, hovering above this. Then we can center on that one. Then we can click the whole thing. And again, remerge them. And there's our driving, and there's our driven. Now we need the central base. We've finished with the triangle, so let's get rid of it. Here, we need a pin that will come up there, and remember that's 8, so we'll make a pin at 7.8 and a pin at 7.8 there. And we've done that. This is what we get. Now we can merge those, but remember, this has a platform of 3 millimeters it's sitting on. This is 5 millimeters, this is 5 millimeters. So this will be lower if we just left it like that. So what I've done is create yet another circle, 20 by 20 at 6, and then we can center those two. And that will just raise them to be the same height, and then we can actually merge the whole lot together. And there we go. There's our 3 components made. All we need to do now is print them off. And once you've printed them off, this is what you get. That goes on there. This one goes on there. And we have ourselves a Geneva drive. Now, remembering that 180 divided by the number of slots, the rule is to measure a few coordinates, and using planes to change your orientation, you could actually make that in any size that you wanted with any number of slots that you might happen to want. And I think that's a pretty cool thing, especially as that can be done in Tinkercad. The process we went through, remember, is the same in any CAD program. I hope it helped. I hope it was of interest to people, and thank you very much for watching.